How are you today? Great. Welcome. I hope you're not too hungry and you will not start leaving like quarter before the end of the presentation, because we will have fun and there are Pokemons at the end, so it's worth staying till the end. I'll be talking about visual search. Who knows exactly what visual search is? I thought so. Whoever uploaded the image to Google to look for other images? There you go. This is visual search. And we will learn today how it works and how you can build it yourself, and we will see the challenges behind it. So my name is Kunysz. My actual name is Alexandra, but I go with the nickname. And I'm a software engineer since more than 12 years. Most of the time I was involved in JVM projects, but also I do some coding in other languages. I'm not afraid of C# or even Python. You will see that in a moment. And since more than 3 years, I work for a Swedish company called Tipser, and we produce a tool for shoppable content and inspirational shopping. And this is something that is not very natural for the developers, especially the backenders, because how we shop is we go to compare the prices. We get the clothes at conferences, so we mostly don't buy clothes. But if we buy something else, let's say electronics, we do the research for 2 weeks and then we finally buy something. But what people do outside IT, they sometimes get inspired and they buy something just because it's in the article, etc. So imagine that you read the article about the trends for this fall, and the article says brown hats are trending this season. And there are products of the hats inside the article, and you can buy it and you can do the checkout over there. This is called inspirational shopping, because you buy only because someone suggested you this inspiration and not because you are in the real need. And I know it's not very natural for us, but people actually start doing that all over the world. So imagine that you look for the Halloween mask and you see that picture somewhere in the newspaper. You don't know that it comes from the Netflix series La Casa de Papel. You don't know that it's Salvador Dali. You just want that mask and you want to have something like that. So you snap a picture and you upload it to Pinterest, and there you go. You even get the suggestions about the name of the series, and if you scroll down, there is a mask and you can buy it directly from Pinterest. So this is how it works, how visual search works. But why am I interested in this topic and why I think you should care about it? First of all, we as humans think with images. We process the images faster than text. Science says that it's 60,000 faster. I'm not sure how they measure that, but hey, it's science, right? And image is international. You don't need to translate anything. It may have different meanings in different countries, but if you look at the picture, you see the same object. And if you ever worked with international search, there is a couple of problems. For example, every language has something called stop words. For example, if you look for the quote, to be or not to be, and you put it to Elastic, you may get empty result. This is because to, be, or, and not are the stop words in English. And every language has this set of words that are completely ignored, and you can take care of that before you work on your search, so it doesn't take this trash data into consideration. And you need to translate names and descriptions, and sometimes it happens that, for example, if you have the same product on many markets, on one market there is a great description, and then on other there is just pictures, and it's really hard to search for that. And you also need to handle wrong images. And what I mean by that is, for example, if you have couple of variants of shoes, and you look for the white shoes, but the first variant is black, then you will get the image of the black shoe, even though there is white variant also. For example, this is our famous example of VitaScore. This means white shoes in Swedish. And if you looked for VitaScore some time ago in our search, this was the result. Not impressive, I must say. So it's somehow related to shoes and somehow related to white. But it's not something that you would expect to have. Because there was an or between white and shoes. Because what Elastic does, it takes one word, which is white, and the second word, which is shoes, and it looks for everything that is connected with that. If we search with the image, we wouldn't have the same problem. So if you didn't take the picture of that mask, and you just want to search for that, so you remember roughly that it was mask, and it was a Halloween mask, and it was red, this is the result you may get. And Pinterest is pretty good in that, because you actually have something similar to the picture that you wanted to search, but the rest is just some random trash, right? So you need to name and you need to know what you're looking for to have effective text search when you're a customer. And is it even red? This is one of the favorite slides of backend developers, because we love talking about colors, right? We love colors, we know the names of the colors, etc. So some companies, some merchants who deliver products, they call this color red. And this is actually pink on that screen, but I have it as red. And it may be the burgundy color, even. Or memory of a sunset. This is the actual name of, I don't know, it was paint or something that was called memory of a sunset. And if your product has memory of a sunset in the field color, there's no way you can find it looking for red. So it's very hard to look for the right products. So you know why it's important, but why now? The computers were ready in 80s. Machine learning is with us since 70 years, and visual search is actually the trend from last couple of years. Oh, and by the way, if you think that it's impossible to snap a picture on the street, upload it to Alibaba, for example, or other shop, and then buy it directly from there, it's with us since like 5 years. So I know there are some people who are not aware of that, but future is now. So if you look at those logos, and you look at Amazon, for example, on Zalando or Wayfair, they sell furniture in States, you know it's e-commerce, right? You know they sell stuff. So you go there, if you look for something, you go there to buy. But if you look at Instagram, Pinterest, or Google Lens, do you spend money there? Not really. You go there for socializing, right? But actually you can buy stuff over there since a couple of years. And this is why visual search is trending. Because of money, money-driven. And because of us, because of customers, because we look for inspiration and we are impatient. The safe web browsers are nice. For example, DuckDuckGo is very nice, but we still use Google because Google knows a lot about us, so suggests best results, right? I mean, not everyone is using Google over DuckDuckGo, but still a lot of people does that because there are just better results. So we are impatient, we want the best results, and we want the technology to read our minds. And this is why e-commerce follows the traffic. So they don't want you to go to the websites where the products are and search for products, but rather they go where you are already. They go to newspapers, they go to publishers, and then they put their products over there so you can buy it directly. So you get inspired and you buy the products there. So this is why it's trending right now, and I think it will be even more popular in the future. Bunch of numbers. So as I mentioned, we think with images. So 90% of information received by our brain is visual. That's why 85% of viewers are more likely to purchase a product after watching the product video. Imagine that. 85% of people. They just see the product video and they buy it. What's even more interesting, 62% of millennials want visual search more than any other new technology. Any other. And millennials are already on the market, they have money, they will drive the market. So this is why I think you should care as developers, because there will be more and more jobs connected to that. And 50% of responders prefer the visual information, ignoring the text completely. So if you buy clothes or furniture, you don't really care about the text anymore. You just look at images. It doesn't apply to electronics and spirits, and I think this is IT here, so we don't really care about visual things when we buy electronics and spirits, but the rest of the world prefer the visual information. So let's talk about tooling, how you can actually play with that, how you can run it on your own. I don't recommend running that on production on Monday, but you can use free tools like, I don't know, Google Cloud or Amazon tools to just play with that and see what happens and see what you can do. So basically there are two ways of building visual search. One is image to text and eventually to the image. And the second one is image to image without any labels. This is like pure mathematics. So the first one, image to text, is simply like labeling all the images and then use these labels to train the model, and then when user uploads the image to search for other images, those labels are used. So in the middle of this process, you can actually see the results. So you can read the labels, because these are like human language labels. And I thought that I will write the tool for that and buy a boat, because it's extremely expensive to sell it. But apparently there is a couple of players on the market. These are just a couple of them. Of course, the Amazon has the tool called recognition, I think, as well. So if you test these tools, you get completely different results sometimes. And the pricing is also different. But the working with that, the experience of reading their API or SDKs is pretty similar. So I recommend trying a couple of them. And this is the example. This is actually the real product from Prada. This is these are shorts, men's shorts. And I have no idea how these tools figured that out, but they guessed that out of so many pieces of clothing, it was shorts that this image is all about. So this model on the left, it comes from Clarify, I think. It's apparel model, that's why it figured out that it's shorts and it's piece of clothing. But the Google also guessed that it's shorts. So you see that the results are a little bit different, and it depends what we are working with, because we mostly work with the fashion items. So we care about color, we care about the shape, the patterns maybe. But if you work with cats and dogs, probably you will use a different model. And I built my own solution, like very simple model in Python, and its libraries. I wrote it on Jupyter, on Google Cloud, but I will show you that on the Colab link. So you can actually go there and play on your own. And I use the Fashionist dataset, and before I jump to the code, I will tell you something about Fashionist. So first there was MNIST. Any of you familiar with MNIST? This is the set, thank you, the set of handwritten digits. You know that data set? This is basically the first data set that you work with when you start playing with machine learning. But the problem with MNIST is that it's very simple. So if your models don't work on MNIST, they won't work at all. But if they work with MNIST, it doesn't mean that it will apply to anything else. So Zalando, some time ago, created fashion MNIST. This is like the same concept of the MNIST, so it's the same number of training set, the items in the training set. So we have 60,000 images, 10 categories. As you can see here, this is like the representation of the set. You have test set with 10,000 images, and all of them are square and flat lying pieces of clothes. And of course, one of 10 classes, like digits. So you can see the code from the last row somewhere. Okay, great. So I thought I may run it, but the Wi-Fi here is not so promising here, so I will just show you the code. And you can go there and play with that on your own. So as you can see, the Python is, I hope, readable, and this is what I loved. And when I thought about the data set, it's just there in Keras, sitting there, so I can just use it directly. And this is how I import the data. So I have the training set and the test set, and it's downloaded. You can see the size of that. So you have 60,000 images in the training set and 10,000 in the test set. And I also created the validation set. You don't need to do that, but it speeds up the learning because you get the feedback during the model training. So I split the training set into training and validating set. Then I presented some results. You don't need to do that, but sometimes it's nice to see what you're working with. You need to do some metrics magic to make it work. There is so you need to add some extra dimension to make it work. And if it's RGB, for example, there will be 3 at the end because you have basically 3 layers of image. It's not grayscale. You need one for red, for blue, and for green, of course. You need to normalize the data, so the maximum number of each value is 1, so all the values are between 0 and 1. And then you need to change labels into vectors. So basically, if you have 10 categories, instead of having a label for that, you just you just create a vector with 1 on the position of this category. So let's say that sandals are the category number 4, then we will have a vector with all the zeros, and on the 5th place there will be 1 just for sandals. And I built the model. This is a very simple model, but if you start playing with machine learning, you don't need to create very complicated models because we need to save the energy, like the keynote speaker today mentioned. And if you add extra layers, usually the accuracy of the model won't be higher, but the learning process will be much longer. So I recommend starting from just a couple of layers with having max pool and ReLU, so it gets faster. And then we train the model. As you can see, we have 10 epochs. And the important thing is that there is this last number, validated accuracy, that is growing. And it's nice when it's growing, because when it stops growing and it goes down, then it means that your model is overtrained. So it fits the training data perfectly, but in the real life, it doesn't. So it's pretty bad when it goes down. And then we evaluate the accuracy of the model, and it's around 90%. So it's not bad for this simple model. And you can test it with the real results from the internet. So I have a couple of examples here on the slides. Yeah, So if you look at these two simple examples, these are the images from the internet. They were, the result is perfect. So the first one is trouser, and it's 100%, the model is 100% sure that it's trouser, and the second one is sandal, and it's also a good guess. But if you look at these examples, which are a little bit more like not typical than the training set, the model gets lost. So it says that it's sandal and this is the bag, which is completely rubbish, right? So it's not really relevant to the training, validating, and testing data sets. That's why we get this crazy results. So what we decided in our project is to do a little bit of cheating, maybe, like meet in the middle. So we decided to use our Elasticsearch for the text search, but enrich our data with the image recognition and with the labels from that. So we will label each image in our data set, and then we will put that into Elastic. And this is also the good solution, because you don't need to build like huge models, you don't need to pay someone to use their model, you just enrich your own tool that you know very well, and for us it's Elastic. So the second way is image to image, and this is where magic starts, because if you look at the labels in the middle of the process, you have no idea what's there, just kind of a bunch of numbers there. So if you choose the model, or you spend like 15 years creating your own, this model creates feature vector for every image. So this is a bunch of numbers. And then when you train the model and you build your offline stuff, and then you start your server and user uploads the image, you basically extract the feature from the image the same way you did for the rest of images in your dataset. And then vectors are compared, and the closest vectors are selected. So this is, like, if you look at that in the middle, you have no idea what's happening there, because this is just a bunch of numbers. So, of course, there are some third-party tools, and I recommend playing with them as well. But this is a very cool project from Yusuke Matsui. He's associate professor at University of Tokyo, and he created a simple image search engine. And it's on GitHub. You can clone that on your own machine and play with that. And there is a offline part and online part. So in offline part, like I said, you train the model basing on your images from your dataset, and then you run the server, and you can upload images that you prefer. And it's built on convolutional neural network called VGG16, and which is trained on the ImageNet. And ImageNet is a set of 15 millions of images divided into 1,000 categories. It's collected by the people of the internet. I love internet for such things. They organize, at least they used to organize the challenges, so they set trends for the image recognition. And this is VGG16. It has a couple more layers than my simple model, as you can see. And it won the challenge organized by ImageNet in 2014. And it also has the accuracy of 90%. So as you can see, my accuracy wasn't so bad, but it was trained on the set of 60K. And this is 15 millions of of images. So it's a little bit more. So this is the code from Yusuke Matsui, and you basically pick the model. You say it's VGG16, and the weights come from ImageNet. You do all the magic, so you process the images so they match. The matrices are right. You process the input, and then you extract the features, and you do that. You create the vectors for every image in your dataset. So Yusuke Matsui, of course, tested that on cats, because this is what you do when you put something in the internet. You test it on cats. But I picked Pokemons from Kaku. Actually, Kaku is a great great tool. If you look for the cool data set to work with, I don't know, superheroes from Marvel or anything else, you can go there and there's like a bunch of cool data sets over there. So I picked Pokemons. This is fairly small because it has like 800 of them, but still it was fun to work with. So this is what the model suggested when I uploaded Pikachu. And this was surprising a little bit for me because I thought about different Pokemons, but you can see that the shape is pretty similar, even though it doesn't look similar at like the first sight. So this is my personal opinion. So I went through all the 800 Pokemons and I picked the ones that I thought are similar to Pikachu. You can download it and play on your own, or you can argue with me that, hey, this pink one in the last row, it's not similar at all, but let's do it during the lunch break. But I will use the Pokemons to show you the challenges, to show you what you need to look at, take a deeper look when you work with building visual search engine. The image quality, and I'm talking not only the images in your training dataset, but also the images that you are ready for. So if you have the flat-lying pieces of cloth, and then people upload the images from the concert, for example, when they are drunk and they try to snap a picture of their idol, to like take a picture of the t-shirt to buy the same one, then probably your model won't work for that. And if you see the picture like that, if you know it's about the apparel, you may suspend that it's a jeans or t-shirt or the jacket, but if it's not apparel, it's just any other picture, it may be about rails or it may be about the city center, who knows. So the model posture is the first thing that can bias your results. And you know that in fashion magazines, models, they not stand like that. They are always in the like fancy poses. So maybe your model will look for those fancy poses instead of looking for the clothes that they are wearing. So this is the first challenge, that you can see that almost all the Pokemons here are in the move. But there is Pikachu at the bottom, so not bad. The background noise. You have like the picture that has lots of noise, like the picture from the concert, for example, and then the result is biased. For example, this Pokemon looks a little bit like the Pokemon Go logo, right? Because of this noise on this picture. So you need to know what you look for. You need to extract the Pikachu from the image before you search. And training data versus real life. Sometimes it's not so easy, because if your images are perfect and they look nice and there is a perfect lighting, for example, and then people on the street upload something like this, then you see that there are Pokemons that never appeared before, right? So the result is completely like crazy, like the picture uploaded. And dataset relevancy. So if you train your model on dogs and cats and then you apply that on fashion items, it won't work. And it's surprisingly good, the result here. So you actually have the Pokemons that are in the shape of hot dog. This hot dog actually comes from the application called Is It a Hot Dog? So there's application. It was created in the TV series Silicon Valley, but it's the actual application. You can download it, and it does one thing. Tells you if it's a hot dog or not. And it's a little bit biased with the ketchup. So if you have the shoe, and you put the ketchup or mayo in the zigzag, then it will tell you that it's a hot dog. So it's not so perfect yet, but you can test it. Actually, there is one more version of that in Scotland. So you know haggis. This is traditional Scottish dish. So there is application. Is it haggis as well? So you can play with that as well. And if you have multiple items on the image, then your search may get lost. So, for example, you have in these results you have the Pokemons that are similar to Pikachu, but also you have the ones that are similar to Ash, the blue ones, and the red ones. So you need to decide. Either you decide it or you let the customer decide. So if you have two items, then you say, hey, do you want to look for this one or this one? And the customer may decide about that. And the color detection. When we work with fashion items, the color is very important, but sometimes it's even like we treat it as a special feature, and it's not always good. So, for example, dominant color versus object color. For fashion items, usually the dominant color is the background color, because you have the model in the middle and the rest is the background. So here, the result is biased by the dominant color, which is blue. This is the color of the background. And you also have some pink ones, which also comes from the background. And the color bias. So if I upload this blue Pikachu, I get many more blue Pokemons than yellow ones. Even though they are still similar, but I get more in the blue. And I'm not sure about this donkey. This is surprising that it comes in the first row as the most similar Pokemon, but maybe what Yusuke Matsui did was the surprise factor. So surprise factor is very important in visual search, because otherwise if you look for similar items and you get looped inside the same set of products, then it's not really good for the customer experience. So maybe this is what's done here. So this donkey, which is irrelevant to like anything on the screen, maybe is the surprise factor of the search. And the last challenge that I want to talk about is the training data size. Because we need, before even starting thinking about visual search, building that, we need diverse pictures from every category and subcategory, and we need to group them by the department, because we want to lower the response time. And this is what eBay does very well, because they get like lots of products and lots of images every day. So they need to retrain the model every day. And if they want to look, because they offer their customers the visual search feature, and if they look for the item inside the whole data set, it will take seconds. And seconds in commerce is like hours. So what they do, they actually have two steps. So the first step is the image recognition to learn about the department of the object. So they know if it's fashion or if it's furniture or, I don't know, motorbikes or anything else. And then they run the actual visual search, image-to-image search, inside this department. So there are two steps, and there is a great article talking about this eBay example. So you need to have great quality of the images, and you need diverse images before even thinking about visual search, because otherwise you need to use the ready-made tools, because it will be cheaper and faster. So if you want to summarize what we learned today about visual search, it's that, first of all, most of us did that but didn't realize it's the visual search. The second one, the visual search blooms now, and it will get more and more popular. And even as developers who are not very familiar with the visual parts, we need to take a deeper look on that. Secondly, you can build it on your own. You can use ready-made tools, test them, or make a combo, so meet somewhere in the middle. And you need good quality images and large training data set. And the training data set needs to be similar to the pictures that you expect from the customers. Like I said, the real-life examples. So if you know that your clients are millennials who will mostly snap pictures on the concert, being drunk, like moving the phone, etc. You cannot use fashionista where the items are like perfectly lying down, right? You need something similar to what you expect. So that was the kind of top-down presentation of visual search. So you got a couple of tools, you can play with them, you don't really need to understand everything what's happening there. But I also recommend you like going bottom up, so learn about matrices and learn how it works. Because at the end of the day, it's all about multiplying matrices and linear algebra. So you won't escape from math here, sorry. And you're awesome for staying with me this long, and I hope you're even more hungry for machine learning now than for the lunch. So you have a couple of links if you are interested. You can find me on Twitter. I'm very active on Twitter, so I recommend following me, and I will put that presentation on Twitter, so you can go to the collab and you can click at all those links and search for more. Maybe you have some questions. Yes.
So you evaluated a number of cloud vendors and saw different results. Was any of the vendor good enough to actually start using it at your company? So was it only the price factor that prevented you from going that way?
So there's a couple of good solutions. I think the Google Cloud is the best, and like the value and the cost is the most promising, because with Google you pay for what you use, and it's a pretty cheap solution, but it's also a very good solution because, for example, they detect colors, and it's not so obvious in other tooling. So this is like a very good solution to start with. I think Site has the most accurate examples, but they are also the most expensive solution. But most of them are the like ready-to-go solutions. You just need to pick the right model, and not all of them have apparel, for example. And for us, for fashion items, it's very important to have that. So if they don't, we just, you just ignore it.
Got it. Thank you.
Any more questions? Yeah.
Thank you. Do you try for build model Amazon SageMaker?
Yes, we tried the SageMaker, but it's like it's much more complicated there, because you need to take care about everything. So I started with SageMaker at work, and I tested my models there, and then I moved to Google Cloud on my own time. And I think I prefer the Google Cloud, but both of them are like really cool tools.
Thank you.
Mm-hmm. Any more questions? All right, so enjoy your lunch and see you around.